Okay, 5, 4, 3, 2, 1. I need to be clear that when I grade your test, when you take this, I'll be grading also off of the language that you're using. There's no more, hey, Mr. Gens, you understood what I was trying to do. Absolutely not. The language must be accurate. If the language is not accurate, then the problem is wrong. These are what I refer to as the essential questions that you must know for the AP exam. I have a total of 8 of them. We're going to spend this week running through those. And everything that you see from here on forward, you may not remember, but trust me, you've learned all of it. I can point to the exact test questions and things that we did to prepare you for these moments. So we start off with some of the most common examples, solids of revolution. Calculator may be required for the following problem, and in this situation, it is. It says let R be the region enclosed from the graph e to the x, and g of x is 3 minus x squared, as shown in the figure above. So you can see we have the parabola here, we have e to the x here. It says find the area of R. Tell me where to start. Top minus bottom, excellent. So I'm going to name this top one. We're going to call it g of x, and I'm going to call that y sub 2 in my calculator. And then this bottom one, I will call f of x. And we're going to call that y sub 1. So find the area. Hattie is absolutely correct. We have top minus bottom. And so if I have the top, would be g of x minus f of x dx. Now,
what happens if you write out the equation?
That's absolutely fine. Okay, plug what in? What am I missing in this problem right now? Balance. How am I going to find the balance?
Find the point of intersection.
Point of intersection on the calculator. So there we go to work. So I go on my calculator and I have y equals e to the x. And y equals, is it 3 minus x squared? 3 minus x squared. And I'm going to zoom standard. I see the exact region right there that I was working with. And what will I do now?
Second calculate is 5.
Number 5, exactly. And so I go close to that point of intersection. I just press enter, enter, enter. And I got negative 1.677. I'm going to call that point A, negative 1.677. I have to find this spot over here. And so I go into my calculator and I can calculate number 5, and I move over to this side and enter, 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 and I get 0.834. B is equal to 0.834. So I've acknowledged those values to 3 decimal places. And so within my work, I can say that I will be doing from A to B. If you want to write the values down, you sure can. This does not just say to write the integral, it also says to evaluate. So we want to figure out the exact area of R. So I could go into my calculator, y equals, and I am doing y sub 2 minus y sub 1. Does anybody remember how I write an equation for y sub 2 minus y sub 1? Yep, bars. And I go and grab my function variables, which is number 2, minus vars, y vars, number 1. And I'm going to take off the equal sign on those previous ones. And I will calculate which number? 7. I will do the integral. And I believe my value is negative 1.677. Is that correct? Mm-hmm. And then I believe I was 0.8. Is it 6.4? 3.4. And it finds that area would be 3.651. In this type of problem on the AP exam, you'd be given 1 point, as well as on your test that you take in this class, 1 point for the correct balance, 1 point for the correct g of x minus f of x, and 1 point for the correct result. We good? Okay. Find the volume when r is revolved about the horizontal line, y is equal to 4. Go ahead and talk to the person next to you. See if you can take about a minute and a half and talk about what does that even look like? What are you going to be doing? Go ahead. Talk. Okay, instead of area, I'm finding what?
Volume.
Volume. And what shape will it make as you rotate it?
Washer.
It's going to make a washer. Did you come up with a washer when you were talking to your friend?
Yeah.
That's what you want to see. And as I look at this washer, I could tell that it is rotated around y is equal to 4. And in this situation, is the original area forming the bottom of the washer or the top of the washer?
Bottom.
The bottom. So therefore, as I draw it, I must make sure I draw it on the bottom. And notice that this bottom portion, this inside portion right there, that would in fact be g of x. And the very lowest part is formed by f of x. So how do we write an integral for a washer? I know I have an integral, but then what?
Pi on the outside.
Pi?
And then you have the distance, the outer radius squared, which is 4 minus f of x.
Yeah, my big radius is going to be 4 minus f of x. And we will square that. And then my smaller radius. Is my smaller radius g of x minus f of x? Or is my smaller radius 4 minus g of x? Yeah, it's 4 minus g of x. And again, we will set that up from a to b.
Are they okay if you mark A and B on the graph and then just write it in like that too?
Like I did right there?
Yeah.
Absolutely. Yep. That would be the way that they would teach people to do it. So, yep. Are we okay to leave that, or do you want to plug that in? We save some time, or do you want to plug this in the calculator? Okay. We got y is equal to, I'm not going to do the top minus bottom anymore. I will do, let's see, parentheses, 4 minus, and I'm trying to remember, it was y sub 1, wasn't it? Is that our big radius?
Yeah.
So I got bars, y bars, function, y sub 1. And we're going to have to square that, minus, parentheses, 4, minus, and then we have our y sub 2. And we're going to square that. And I will calculate that number 7. And I'm going to go from negative 1.677 over to 0.8. I can't remember. Is it 3? 4.2?
3.4.
3.4. And it finds it to be 17.109. Is that my final answer? Right. I have to put the pi in it. So 17 point, what was it?
109.
109 pi. And if you wanted to multiply out the pi, that would be just fine. Do you have to do what?
Multiply.
You could leave it like that, or you can multiply it by pi. Either way, they'll accept that answer.
Could you draw what the actual area would be for that washer, what it looks like?
Trying to think. So
Yeah, like that. Like, what does it look like? So this, like,
No, this is what it looks like. So we're taking this area right here. We're taking that area and we're revolving that area up and around. So as that area comes up and around, it comes around and comes back down.
So that's a space in the middle.
Yep, that's your space in the middle. Yep. Okay. All right. So this one we've talked a little bit about. It says R is the base of a solid, and for each solid at each x, the cross section perpendicular to the x-axis is a square. Find the volume of the solid. And this is often where people start to take points off when you get to the AP exam, but I don't think it's all that bad. It's saying a cross section perpendicular to the x-axis. So namely, when you go ahead and you, whoop, sorry about that. When you cross it like this, okay, if that's the base, it extends up at you, okay, it comes off the surface, and what shape does it make? A square. So all we want to do is we just want to find the volume of that square. First of all, what is the width of the square? Is it horizontal or is it vertical? So it is dx or dy? Dx. So we know we have dx.
Why is it square and not rectangle?
What's that?
Why is it square and not rectangle?
Because it says that it is a square. Okay? So now what I need to do is I have that square piece, which I will mark right here. Whoop. And you already told me that measures dx. What is the height of that square? How do we determine the height? Top minus bottom, which would be g of x minus f of x, correct? What is the height of the square? Oh, what's this dimension of the square? Why? By definition of a square. So if you multiply this all out, you get g of x minus f of x, that quantity squared. And that's the volume of one of those shapes. We don't want to do one, we want to do an infinite number, so we just slap on an integral and we integrate from a to b. Do I need pi in front? Why? Square doesn't involve pi at all. And so that's all we have to do. So I'm going to go ahead and get back to my shape here. I'm going to clear that and parentheses. Whoops, sorry. And in my variables, I have my y variables. I select, we did y sub 2, correct?
Yeah.
And we're going to subtract y sub 1, parentheses, and we square that. And again, we keep the same bounds of integration, which we'll see if I can remember now, negative 1.677. That is my, and then I have 0.834. And I've got 6.358. Everything that you see right here is what they would like to see on the AP exam. Now, there's different ways of writing it. You can put in your bounds to 3 digits. You can go ahead and write out the functions, but this is the work that they really appreciate seeing. They like to see you draw the washer. They like to see the square. They're just trying to give you points, but they want you to communicate correctly what you're trying to do. Could you do a problem like that? Great. What if they don't give you a calculator? Okay, so we'll end with this one today. It says a calculator may not be used for the following. For the AP exam, you'll have 2 sections of multiple choice. One section you'll be allowed to use a calculator, and one section you will not. And then they'll move to the free response. You will have a total of 6 free response. For 4 of them, you will not be able to use a calculator, and for 2 of them, you'll be required to use a calculator. Okay? So When you get to the non-calculator section, we got to be ready to go. So let's see what we can do. It says calculator cannot be used. Same type of problem. It says let R be the region enclosed by sine of x and x minus pi. The y-axis is the vertical line. X is equal to pi as shown in this figure. It says find the area of R. So we want to be able to find this area right here. Oh, that's an eraser. I want my highlighter. We're going to highlight that. Feels like that kind of a day. Yeah, I just caught the purple theme today. So let's just first look at this obvious piece here. What's the function on top? Whoop. Yeah, so we could see very clearly that this is sine of x on top, or in other words, f of x, and that the function on the bottom is g of x. So the other two things I need are my bounds. What is the bound over here?
0.
0. And what's the bound here? Pi. And let's just, try to remember that, if we wanted to be able to find those, it's quite obvious that this function right there has an x-intercept equal to pi and a y-intercept equal to pi. And sine of x, from making a graph of sine of x that it crosses at 2 pi, and then at 1 pi, it has this peak at pi over 2. So you could sort that through in that situation, yes.
So how do we know that it ends right here?
Just in that it does say, and they'll be clear on the AP exam, more clear than I am, but it says the y-axis is part of that boundary. And it also says that x equals pi, the vertical line. I just forgot to put that in there. But so 0 is one of the boundaries, and pi is one of the boundaries. So we're enclosing in that region. Okay, so we're going to find the area, and we're going to do it without using our calculator. So integral what? That's x minus pi.
Oh, we don't.
Well, no, that's the bottom, isn't it?
Yeah.
So the top is sine of x. And if you wanted to write f of x minus g of x, you could, but I'm going to write it out because I need to actually find these antiderivatives. Can't use my calculator. So then what?
Minus x plus pi.
Minus x plus pi. And I'm going to integrate from 0 to pi. Okay, antiderivative of sine of x. Negative cosine of x. Antiderivative negative x. Antiderivative of pi. Pi x. Evaluated at pi and 0. Am I going to have to plug in 0 eventually? Yeah, because the cosine of pi is obviously what? 1, and so that's going to impact our result. So we're going to go ahead and plug in pi. So the cosine of pi is, as you said, what? And times negative 1 is 1 minus pi squared over 2 plus pi squared minus, then we're going to do our next part here. So when we plug in 0, we get the cosine of 0 is 1, make it negative, I get a negative 1. And then we get 0 the rest of the way through, don't we? So 1 minus a negative 1 is 2. And I'm just going to write minus pi squared over 2 plus pi squared. Okay? And that's more than sufficient. You could go ahead and find common denominators. It's really not necessary. On the free response, they'll allow you to leave it just like this. So
Is that just the same as pi squared over 2, like positive?
yeah.
I want to make sure that was right.
Yep. So if you want to create common denominators, that way you can, not required. Okay. So then we move on to letter B. Notice that in letter B, we don't have to actually make a calculation here. It says write, but do not evaluate an integral expression that gives the volume of this solid generated when R is rotated about the line, horizontal line, y is equal to negative pi. Go ahead, take a minute and a half, see if you can design this on your own. Talk to the person next to you if you'd like to, but try to write this one on your own. what shapes did you get?
I'm ready.
Got a washer? I get confused when I don't draw the shape, so I'm going to go ahead and draw the shape. And I notice that in this situation, this washer, the original area is forming the top of the washer. So I've got in the middle here, x is equal to negative pi. In that space right there, I have x minus pi, which is g of x. And on the top, I have sine of x, which is my f of x function. Do I have those right, f of x and g of x? Okay. So as I look at my washer, pi times the integral, and again, we're going 0 to pi, of the big radius is going to be f of x minus negative pi, or f of x plus pi, that quantity squared, minus, and then my small radius is going to be top minus bottom, so g of x plus pi, quantity squared, dx.
So if I wrote that as the actual ones, would it just be x because x minus pi plus or minus the negative pi?
Yep.
So they cancel.
Yep, that's absolutely fine. Yep. Okay. Okay, try letter C on your own. Can you do letter C? So we want to start with how do you find the, so first the width of this, since the width is horizontal, it's dx.
So it's
And then, so we have the triangle, you have 1/2 base times height. So you can see that this dimension is just top minus bottom, so you have f of x minus g of x.
how is it quantity?
So it says that for the solid at each x, so at each x value within here, the cross section perpendicular to the x-axis. So if we draw this against the x-axis like that, it comes off at us like an isosceles vector. That's what that means.
So this part is dx.
Yep.
And the top minus one, I get that.
Yep.
How do you choose?
Well, it's isosceles, so they're the same dimension. So this is also f of x minus g of x. And so we have 1/2 times that times dx. All right, I draw the shape as is coming off the page to me. I've got f of x minus g of x. And I've got f of x minus g of x because it is an isosceles right triangle, meaning that the two sides are the same. An important note to make here, folks, is it says this. It says where one of the legs of the triangle lies in the region of R. So what that means is that this leg that you're seeing right here, it lies within this region. If it said the hypotenuse lies in that region, we did an example like that one day in class, that's a little bit more complicated, okay? So we do have one of the legs lying within the region, okay? So that's helpful. We know that this is a dx type problem. So again, we have the integral from 0 to pi of these all multiplied together, which would give f of x minus g of x, that quantity squared. And then we do multiply by pi, no, 1/2, because triangle is 1/2 base times height. And so that's our integral.
Does it matter if you write the pi or the 1/2 on the inside or just the outside?
Nope. So what we just did today is we looked at a review of the area problems. You should be excellent at area. Area and volume, that we want to check that one off. If you see an area volume problem on the test, you want to say, yes, I know how to rock that one. Tomorrow, we are going to look at motion. Have you seen motion before? Yeah, acceleration, velocity, speeding up, slowing down. We're going to look at those examples. And then we'll move on to the ones that are a little bit more challenging. Situations I call accumulation, arriving and departing. And then we have just various integrals and slope fields and stuff like that we're going to have to get into as well. So, yeah, so nice job. I will hand back your tests.